All right, vertex form. So as I said, this is kind of a topic from Algebra 2, typically, that I find pretty interesting and pretty relevant. So vertex form, just like with lines, we had different ways of writing the equation of a line, right? We had slope-intercept form and standard form. We also had point-slope form. So the way that we've been writing parabolas, something like y equals 3x squared minus 6x plus 7, this is sometimes called the standard form of a parabola or of a quadratic equation. Okay? And as we've seen, it's kind of tricky to graph from this, right? We have to use the formula x equals negative b over 2a. We have to plug that in to find y. There's a lot of steps to graphing it. Vertex form looks totally different, but is much easier to graph. Okay? So here's an example. Y equals x minus 2 squared plus 3. This is the equation of a parabola or a quadratic equation in vertex form. So I want to graph this. Let's just use a t-chart to start out. But you're going to start to see some patterns pretty quickly with these. Okay? So here's my axes. And then here's my t-chart. What might be a good number to plug in for x here?
0.
Okay, 0 would be okay. We'd have 0 minus 2, so that'd be negative 2 squared, which is 4 plus 3 is 7. So that would, yeah, I mean, we could. But there's a number that would be even easier to plug in.
1. No, 2. 0,
Yeah.
4.
Why is 2 a really good number to plug in here? Why is 2? Yeah.
Because the 2 2's cross each other out.
Yeah.
You get 0.
If we chose 2 for x, we have 2 minus 2, which is 0 squared. This whole thing right here collapses if we choose 2 for x. So if x is 2, y is just 3. It's just this number right here. X is 2, y is 3. So we could put that point on our graph. 1, 2, 1, 2, 3. Okay.
But why is y 3?
Why is y 3? Because y equals 2 minus 2 squared
Which is
plus
0
3.
squared, which is just
0 squared is 0. So it's y equals 3. Right? If we choose 2 for x. So that makes x a really good, 2 a really good choice for x.
And then is it just standard parabola?
I'm having trouble drawing this. So,
What about the plus?
yeah, you just made a really good guess. This is called vertex form for a reason, and it is just our standard parabola guy from here.
What about the plus 3? What is that? But how can you make it different parabolas, like 2?
Well, let's finish graphing this one first, and then we'll talk about different things. Okay. So we can see that if we plug in different numbers. Like, let's plug in 1 and 3. If we plugged in 1, right, we'd have 1 minus 2. That's negative 1 squared, which is 1, plus 3 is 4. So if we go over 1, we go up 1.
What?
1, 4 from this point is over 1, up 1, right? That sounds kind of familiar. So 1,
So if you had done that instead,
4.
would that
What
be
happens if we
vertex?
plug in 3 for x? Let's think about what if we plug in 3 for x? Wait, don't we get the same thing? Because 3 minus 2 is 1, and 1 squared is the same thing as negative 1 squared.
What?
So if we plug in 3, we also get 4. plug in 3 for x, and you get 4 for y.
That's the other side.
So that's kind of the other side.
Nate, but if you start with that number, then how are you supposed to get, like, okay. So if you start with a different number than 2, then does that mean that dot that you put is the new vertex?
We're not quite there yet. Let's just graph this one. So we can start anywhere, right? I mean, like you propose starting with 0, and what did we get with 0? Like 7, right? 1, 2, 3, 4, 5, 6, 7, right? Now, it doesn't really matter. If we had done that first, we still would have gotten all these other points in the order that they're in. We know this is going to be a parabola because we have x squared in here, right? So let's just start connecting the dots, right? We can kind of see how this parabola takes its shape. The important thing to realize is the vertex is that first point we plugged in, right? It's the opposite of this, so 2, because 2 minus 2 equals 0 for x, and then the y is just that number off to the side.
So
And then from there, what's the coefficient on x squared?
1.
Yeah, there's nothing in front of x
So if you
squared
had
here.
negative, you could.
So we just go over 1 up 1 over 2 up 4.
So if you
Let's
had
do
a
another
negative, would it
example.
be a place, and then if you have like a 2, would it be
Yeah,
over 2?
we'll get there.
Nate,
We'll get there. Eventually.
Nate, but wait. But if you plugged in 1 comma 1 for x, and then you got 4, and you plotted that point on your line, then would that become your vertex? Because that's the first number you can plug in.
No, we did plug that in. I just
Yeah.
did that,
Yeah, I know.
right?
But would that be the
It doesn't matter which order I plot these points in. Let's plot them in the
You have to
opposite order.
plot them all though, or can you
1,
just
2,
get the
3,
right
4,
vertex
5,
first
6,
and then go
7.
over 1 up 1 over 2 up 4?
Sure. Yeah,
But you
that's
have to
where we'll
the
get
right
to.
vertex.
It doesn't matter which order I plot the points, right? If I do 0, 7, and then 1, 4, wait, 1, 2, 3, 4, 5, 6, 7, yeah. And then 1, 2, 3, 4, and then 2, 3. This is, I plotted this point first, right? But it's not my vertex. I can see that my vertex is down here.
So if you
I mean,
had-
I could plot infinite points. If I picked, I could pick like 0.1 for x, and I'd get something like that for y. Like, all a parabola is just an infinite series of points, right, that are connected. But I'm just trying to pick easy numbers to plot, because I know the shape of the parabola. Like, I know what shape I'm going to get, roughly. So I can use that knowledge that I already have to help me figure out what the graph's going to look like. I don't literally have to plot every single point to make the
But how do
parabolic
you
shape.
get the vertex without
Yeah,
plotting?
so let's try what we just did again with a different example, and let's
Is
see if
just
it
like
gives us the
always
vertex
2
again.
then? Because
Let's
it would do
see. So here's another example. Y equals x minus 5 squared minus 6.
So,
So- What point might we choose?
but like,
Okay,
what
we
do you-
could choose 5 for x. Could I choose something else if I wanted to?
Yeah, but like,
Totally.
is it just that rule, like, that it's, your vertex will be whatever number is in the parentheses with x? If you plug that number
Well,
in for x?
I know the answer to that. I'm trying to get you to see the answer.
So
to
is it yes? Because
I'm not going to tell you the answer to it yet. So let's try it. Let's just try plugging in 5. Because 5 is easy. 5 makes this whole thing go to 0. So if x is 5, what is y? It's just negative 6. Do you guys see where that comes from, or should we go through it? Okay. All right. So let's graph. Let's plot that one point. We have 1, 2, 3, 4, 5. Negative 1, 2, 3, 4, 5, 6. So it's somewhere like this. Now, what point might we want to plot next? If we think about a parabola, yeah, we often go over 1, right? So instead of 5, let's try 4. What do I get if I plug 4 in? Well, 4 minus 5 is negative 1. Squared is 1. Minus 6 is negative 5. So if I plug in 4 for x, I get negative 5 for y. Plug in 4 for x, and I get negative 5 for y. If I were to describe the relationship of these 2 points, from here I went over 1 and up 1 to get here. So let's see, that's something familiar to us from graphing parabolas. Let's see what happens on the other side. What if we plug in 6 for x? What do you get when you plug in 6 for x? You take 30 seconds or so.
It's negative 4. I mean, negative, yeah, it's negative 4. If you plug it in.
Negative 4, negative
Oh,
5.
yeah, negative 5, sorry. I was
Negative
looking at
5? So I'm just hearing negative 5 now? We plug in 6? Yeah. It's negative 5.
So then what do you do,
Okay.
like 3?
So then, yeah, I mean, if we kind of follow this pattern we've noticed, let's try plugging in 3. Go over 1 more. So if I plug in 3 for x,
You get negative 2, right?
I'd get negative 2 inside the parentheses. Squared is, negative 2 squared is what?
2, right?
Negative
4. Yeah, positive 4, right? Negative 2 times negative 2, positive 4. Minus 6 is negative 2. Yeah. Okay. So then I have a point like right here. And let's just keep going. So let's go 1 to the other direction. The number after 6 would be 7. Plug in 7, what do you get? Oh, it's awesome. So I'm getting some symmetry around this point, right? If I plug in 4, I get negative 5. If I plug in 6, I get negative 5. Plug in 3, I get negative 2. Plug in 7, I get negative 2. The thing about this is, eventually we're not going to really need all these other points. Why?
Because if you know that, because if you know that you're plugging in 5 for your x, or 2 or whatever
Uh-huh.
is inside the parentheses, and then you get the so it's going to be whatever you plug in for x, and then the one on the outside of the parentheses, then you know it's either standard parabola guy, or if there's something on the outside of the parentheses, then you just follow that, like standard parabola.
Yeah, so you're even a step ahead of us. But let's look at this. Again, this point where I picked 5 for x and got negative 6 for y, again, this was our vertex. Right? So we've been graphing parabolas by finding the vertex and then just going over 1 up 1, over 1 up 1, over 2 up 4, over 2 up 4. So that pattern will still work with vertex
So
form.
how do you like always know, I don't know if this is gonna make much sense, but if a parabola is like wide or skinny, because like,
If there's something, it's like
but there could
you
be
know how
like,
like there's the x, like when we're looking at standard parabola, there's like an x squared. Well,
yeah.
like that's what, if you imagine that x squared is the parentheses, then anything on, if there's something right next to the parentheses, like a negative or a 2,
Right.
it acts the same way as if it was just x squared.
yeah, I
Okay.
I get that if like if it's a bigger number, the parabola is gonna be like skinnier, but like could you necessarily always tell they're looking at it? Because couldn't like someone represent it as like each dot on the graph like super far apart and then have it be
Sure.
like all wide, but
Sure.
it's actually not.
Totally. All right. X plus 2 plus 1. So let's try graphing this, combining what we've just learned, which is it's pretty easy to find the vertex of this parabola,
Wait, it's not squared?
plus what we were doing before. Oh, sorry. Totally. Yeah, otherwise it would have just been a line, right?
I like that one more.
Okay, so what's our vertex here? Do you guys see it? What's the vertex?
Negative 2 comma 1.
Negative 2 comma 1. So I find my vertex, negative 2, 1. Now I'm just going to use the pattern that we've established for parabolas. From negative 2, 1, I'm just going to go over 1, up 1. Right? over 2 up 1, over 2 up 1, 2, 3, 4. And then mimic that on this side. And at least 5 points, so I have my 5 points. And that's our parabola. Think about how much faster that is
Wait, how'd you get
than the
negative
standard.
2? I didn't see that.
How did I pick -2? What made us? I didn't do it. You guys came up with it.
Whatever's in the parentheses.
Yeah, it's just the opposite. What would make this 0? What would make this 0 if x were -2? Right? If x were 2, 2 plus 2 would be 4, right? So x would have to be -2. So the x is the opposite of what's in the parentheses. The y is the same as what's over here. This is so much easier than graphing parabolas using standard form. It's way faster.
Is there a way to change standard form into vertex form?
There is. But what you have to do is find the vertex. So it's not super helpful. All right, let's take a look at one more example like that. Y equals x plus 3 squared minus 5. Okay, what's my vertex?
-3, 5.
Yeah, -3, comma, -5.
Wait, why negative? But the 5 is negative though.
The 5 is negative,
So,
exactly.
but
So think about it. If I plugged in -3 for x,
oh, never
what
mind.
would y
Never
be?
mind.
Y would be 0 minus 5.
Yeah, I got confused.
Uh-huh. It is confusing, right? It's the opposite of x, but it's the same for y.
Okay.
Opposite for x, same for y. So we're just using that pattern. Now I'm just going to go from this point over how many and up how many? Over 1, up 1, which is here, over 2, up 1, 2, 3, 4. And then I have my 5 points. I can draw my parabola. Okay, so we have to look at one more thing though, because when we were graphing parabolas before, we didn't always go over 1 up 1 and over 2 up 4, right? Sometimes we might go over 1 up 2 and over 2 up 8. So how are we going to know to do that with vertex form? And I have to show you this because I haven't actually technically told you what vertex form is yet. So if we had something like this, y equals 2x minus 2 squared minus 6. This is vertex form. But what's different about this equation than the one we looked at? So what do you think this 2 represents?
It's part of the y and it's the over 1 up 2 thing.
Yeah, it's the over 1 up 2 thing. Can anyone prove that that would be true? Can you look at this and give me a reason why you think that's true?
Because it's the parentheses times 2. That's
Okay.
It's A. It's like the A.
This is like A,
And that's like a.
but the 2 has to multiply times the other stuff in the parentheses too, right?
No.
Yeah, it does, distributive property.
Well, then you can just keep x as 0 then, right? No, you can keep x as 1.
Wait,
X, no, -1, sorry.
Wait, but then
No,
we
no,
don't
no.
have negative
1. It's 1.
Yeah, or no.
Well, I'd have to do the squared first, right?
Right, but if you plugged in 2 into
Mhm.
the parentheses, you get 0. So 0
Okay.
times 2, that'd be -6. Okay, got it.
Uh-huh.
Yeah.
Yeah, so the vertex is the same,
Do you
right?
do the 2 first or the actual other 2?
So
The
the
square
first
and the
thing I'm going to do is plug in 2 for x. And what would I get for y? -6. So I go 1, 2, 1, 2, 3, 4, 5, 6.
Can't remember the diagram.
That's my vertex, because we've already kind of proved that that point will create our vertex. And then you guys are totally right. But as you're doing these for homework, I want you to think about why are you right? How come this is the same thing as A? So we're going to go over 1, up 1, 2, over 1, up 2, over 2, up, 1, 2, 3, 4, 5, 6, 7, 8.
So do you
And the
have-
same thing
do
on
you
this
have-
side.
Do you really have to do any solving, or can you kind of just guess that? Can you
Yeah.
kind of just assume that it's the?
Because of
Because
these
it's the
patterns, you have to do very little like algebra to graph a quadratic in vertex form, right? Because you can probably find the vertex in your head. It's just 2, -6, and then you go over 1 up 2, over 2 up 8 because of this.
If the 2 was negative, would you go
Yeah.
down?
If this number were negative, you'd go down, right? Does that make sense? So this number here is A.
Is there ever a B?
There isn't. We can't see B in this form. It's not in this form. These actually do have names. This is called H and this is called K. And the vertex point of any parabola is H comma K.
So
Okay.
so like if
This is technically negative H because of this, but I just like to say like this. Well,
so like what if you
guys see what I'm saying.
will we ever get like 1/2 times x minus 2 squared, like
You could
so that
Totally.
you would just do like
over 1 up
over-
1/2
okay
over 2 up half of 4, which is 2. So you could totally have a fraction here, and you just use that same pattern.
and so you can pretty much just ignore the number in front of the parentheses until you like are graphing.
Yeah, because again, if I pick 2 for x, this whole thing is just 0. 2 times 0 is 2 times 0 is 0, right? So it doesn't matter until we get to the other points. So vertex is the same, and then we use this to figure out how many we go up. Go over 1 up 1 times 2, over 2 up 4 times